predicting the stock market. It's a dream for many, a puzzle that everyone wants to solve. Imagine knowing whether a stock will go up or down tomorrow. This knowledge could bring wealth and financial freedom. While predicting the future perfectly is impossible, we can get closer with the power of machine learning and something called LSTM. LSTM, or long short-term memory, is a special kind of artificial intelligence. It's like a super-powered brain that remembers patterns in data over time. Think of it as a detective for stock prices. It analyzes past stock movements, learns from them, and then tries to predict future prices. This essay will be your guide to understanding LSTM and how to use it for stock market prediction. LSTM stands for long short-term memory. It's a type of recurrent neural network, or RNN. Don't worry, we'll explain it simply. Imagine a neural network as a computer program that learns from data. It's made of interconnected nodes, like neurons in our brain. Now imagine a network that can remember what it learned from previous data points. That's an RNN. It's like having a memory that helps it understand sequences. LSTM is a special kind of RNN that's really good at remembering long-term dependencies in data. This is crucial for stock prediction because stock prices are influenced by events that happened days, weeks, or even months ago. Before we can start predicting, we need data. Lots of data. We need historical stock prices, the opening, closing, high and low prices for each day. You can get this data from financial websites like Yahoo Finance or Google Finance. There are also Python libraries that can download this data directly. Once you have the data, you need to clean it. This means handling missing values and formatting the data in a way that our LSTM model can understand. We also need to split the data into two parts, a training set and a testing set. We use the training set to teach our model and the testing set to see how well it learned. Now, the exciting part. Let's build our LSTM model. We'll use Python and a library called Keras. Keras makes it super easy to build powerful neural networks. First, we define the architecture of our model. We need to specify how many LSTM layers we want, how many neurons each layer should have, and so on. It's like designing the brain of our stock predictor. Next, we compile our model. This means choosing an optimizer, a loss function, and some metrics. These are technical terms, but basically they tell our model how to learn from the data and how to measure its performance. Think of them as the learning plan and the grading system for our model. Section 5. Training your LSTM model, a step-by-step guide. With our model built, it's time to train it. We feed our training data to the model and let it learn the patterns. The model adjusts its internal parameters to minimize the difference between its predictions and the actual stock prices. This process is called backpropagation. We repeat this process for multiple epochs. An epoch is one full pass through the training data. During each epoch, the model gets better at predicting stock prices. We monitor the model's performance on the validation set. This helps us prevent overfitting, which is like the model memorizing the training data instead of learning general patterns. Section 6. Time series data and neural networks. Stock market data is a type of time series data. This means the data points are ordered in time, and the order matters. Traditional neural networks assume that data points are independent. But in time series, each data point is related to the previous ones. That's where LSTM shines. It can remember past information and use it to make predictions about the future. The memory in LSTM allows it to capture long-term dependencies in the data, making it ideal for stock price prediction. Section 7. Predicting stock prices. A practical example. Let's say we want to predict the closing price of Apple stock. We gather historical data for Apple stock, clean it, and split it into training and testing sets. We then build an LSTM model with one LSTM layer and one dense layer. We train our model on the training data and evaluate its performance on the testing data. We can then use this trained model to make predictions on new, unseen data. For example, we can feed the model the last 30 days of Apple's stock price and ask it to predict the closing price for tomorrow. Section 8. Benefits of LSTM for stock price prediction. LSTM offers several benefits for stock price prediction. First, it excels at handling time series data. It can learn long-term dependencies in stock prices, something traditional methods struggle with. Second, LSTM is highly adaptable. We can customize its architecture, adjust its parameters, and even combine it with other techniques to improve its accuracy. Furthermore, LSTMs can handle large datasets. The stock market generates massive amounts of data every day, and LSTMs can process this data efficiently. This makes them suitable for high-frequency trading and other applications where speed is crucial. Section 9. Limitations of LSTM in stock market prediction. While LSTM is powerful, it's not a crystal ball. It has limitations. The stock market is incredibly complex, influenced by countless factors, many unpredictable. News events, economic indicators, even social media sentiment can impact stock prices. LSTM can only learn from the data we feed it. If the data doesn't capture all these factors, our model's predictions will be limited. Moreover, LSTM models can be computationally expensive to train. They require substantial amounts of data and processing power, which can be a barrier for individual investors. Additionally, past performance is not indicative of future results. Just because an LSTM model performed well in the past doesn't guarantee future success. The market is constantly evolving, and our models need to adapt.